Good morning 11th class. Today I'll explain nature of light and electromagnetic radiation. Okay, actually you know that in case of electromagnetic radiation, okay, in case of either it's a discovery of electron, proton, nucleus, there is a very important role of radiations, because when we pass some radiation, then they form, either they produce fluorescence in something. So there is, okay, again very important role of radiation. Okay, so first of all, okay, I'll explain that one is, that is regarding to electromagnetic radiation, what's the nature or something. Okay, now in case of light, I think you know light के ऊपर बहुत सारे discoveries होते रहते हैं कि what's the nature of light, how it moves or how they travel in space and all. Okay, so that for example in earliest view, okay, generally that light is regarded as a particle nature, ki means light have a particle nature, just because just because of the fact or experimental facts such as reflection or reflection of light. Okay, it shows what, okay, that one is light have a, that one is particle nature. But again it failed to explain, or either you can say because all these things, that reflection and reflection, that is because of Newton ने सब कुछ ये सारी चीज़ें वो करी थी, but it failed to explain this way. Particle nature of light failed to explain what, the phenomenon of interference and diffraction. Okay, that one is again both the terms or other things that you will study in detail in physics, not in chemistry. Okay, because it's required there only. Okay, but क्या कहते हैं, this nature failed to explain these things. So later on that Huygens proposed wave like character of light. Okay, that again according to Newton, or we can say Newton theory, या जो अलग अलग साइंटिस्ट ने थ्योरी दी थी, that light have wave nature, sorry, the light have particle nature. But later on, because he failed to explain this thing, interference or properties of diffraction, the Huygens proposed wave like characters of light. Okay, with the help of his theory, that one is wave theory of light, and he explained this thing, the phenomenon of interference and diffraction. But that thing you will study in physics later on. But our main concern is with electromagnetic radiation, and that one is nature of light. कि actually अब क्या पढ़ेंगे हम कि what is the nature of light. Okay, now in case of this, that first of all, that James Clerk Maxwell proposed that light and other forms of radiant energy, जो भी energy, what is the meaning of radiant energy? Okay, the energy, okay, is emitted from any source, कुछ भी हो सकता है, either it's a heated rod, either it's a filament of a bulb, through which electric current is passed continuously in the form of radiation. That one is known as radiant energy. Okay, so according to Maxwell, that he proposed that light and other forms of radiant energy propagate through space in the form of waves. Okay, अब इसने भी वही बात कह दी, तो नया क्या था? But he said what, that these waves have electric and magnetic fields associated with them, and that is the reason, okay, these radiant energy are known as electromagnetic radiation, or either you can say electromagnetic waves, because okay, they are associated with electric as well as with magnetic field. Okay, now some characteristics of electromagnetic radiation. First thing is, in this one, you know, radiant energy already explained. Now radiation consists of electric and magnetic field oscillating perpendicular to each other, and both perpendicular to the direction of propagation of radiation. Okay, these radiations are known as electromagnetic radiation. Now just see how it propagates, ये कैसे travel करती है. Now just see in this one. Okay, now just see, this one is electric field and one is magnetic field. Another one is, it's a direction of propagation. So how they are moving, just see, perpendicular, both are perpendicular to each other, and this one is direction of propagation, that one is also perpendicular to both angle x. This one is y, another one is also, okay, both are perpendicular. And how they move, they are moving like waves. Just see, they are traveling like waves, but perpendicular to each other, oscillating like this and perpendicular to each other, and this one is also like this. Okay, so they are associated with both magnetic as well as electric field. That's why this one is known as electromagnetic radiation. Now second thing is, when they propagate, or either you can say when they travel, okay, so generally they don't need any medium, okay, to propagate. Okay, so these waves do not require any medium for propagation. Okay, for example, we have different type of rays, either it's X-rays, gamma rays, cosmic rays, so many type of rays we have. Okay, so they don't need any medium. Now next thing we have, that one is regarding to electromagnetic spectrum. Now just see electromagnetic spectrum. All of you know about Vibgyor. Okay, so just see that one is a simple reason, okay, in which things are visible when white light is passed through a prism, then it is split into 7 colors. That one is Vibgyor. But electromagnetic spectrum is something else. Now in case of electromagnetic spectrum, होता क्या है electromagnetic spectrum? Simple, the arrangement of different types of electromagnetic radiation in the order of increasing wavelengths or decreasing frequency is known as electromagnetic radiation. As I told you that they don't need any medium for propagation, and example given X-rays, Y-ray, gamma rays, cosmic rays, visible. So we have so many reasons here, so many radiations. Okay, so arrangement of these different types of electromagnetic radiation in the order of increasing wavelength or decreasing frequency, that one is known as electromagnetic spectrum. Now just see, this one is a spectrum. Okay, arrangement. Now first of all, just see gamma rays, X-rays, UV rays, IR, microwave, FM. Okay, that one is long radio waves. Okay, that we have different, just see, reasons for wave, and in this between UV and IR we have one reason, that one is a visible reason. Okay, and this one is arrangement decreasing frequency and increasing wavelength, and this visible reason, okay, just see visible reason, the range is between, that one is from 400 to 700 nanometer. Okay, somewhere it's written 750 also. Okay, it's not exact 700, so 750 also written in your NCRT. Okay, now just see so this one is around 400 to 700, 750, and up to 800 also some portion is visible. Okay, now this one is Vibgyor violet color, indigo, blue, green, yellow, orange and red. So this one is your electromagnetic spectrum, this arrangement, simple arrangement. Okay, thank you.